Welcome back to my series on being an applied statistician with JAMOVI. In this video, we're going to deal with a test called the Mann Whitney U Test, which is a test for comparing two groups when you have ordinal data or when you have interval data which is not normally distributed. Okay, let's start as we always do with a consideration of our statistical test decision tree. Now, as I just said, we're talking about a test of difference. We are talking about one of two situations, primarily ordinal data, which by definition is not normally distributed, and we're talking about a comparison of two groups. Now, if you have interval data and you do a test of normality and it's not normally distributed, you would also do a Mann Whitney U test. So this is parallel to the independent t-test under the condition that this is either ordinal data or that this is interval data that is not normally distributed. When do we use the Mann Whitney U test? Well, let's consider the following research question. Is there a difference in the preference ranking for writing poetry for students in a meaningful literacy class and in a 101 composition class? So in this question, students are asked if they prefer to write poetry and to what degree do they prefer to write poetry. So is this the most desired, most preferred writing task, or is it perhaps the least desired writing task? Please note that this is a rank order question, right? A preference ranking is a rank order question, and therefore by definition is an ordinal data type. So let's go over the question analysis. Grouping variable, when we have type of class, and we've seen this before in previous videos, we have a meaningful literacy class and a 101 composition class. The number of groups, well, we have two groups, right? We only have two classes, meaningful literacy and composition. Are the groups independent? Well, the answer to that is yes. We have different students in each group. So up until this point, it is exactly the same as, let's say, an independent t-test. But now comes the difference. What's our outcome variable? Well, it's a poetry preference ranking with a 5-point scale. 1 equals most preferred and 5 equals least preferred. What type of data is this? Well, this is an ordinal rank. It's ordinal data. It's rank order preference. So what do we need? We need a test that compares two independent groups of students with one ordinal outcome variable. Okay, let's take a look at a schematic description of this. So you recognize actually this design because it's exactly the same as the independent t-test. We have two groups, we have one shared measure, and then we have results for group 1 and group 2, and we're going to compare them. The difference is that the Mann Whitney U test compares mean rank of group 1 compared to mean rank of group 2. So it's a rank order that is being compared between these two. Okay, so what does the Mann Whitney U test do? It compares the mean rank of the outcome measure for each group and tests whether the two mean ranks are significantly different from each other. When can you use the Mann Whitney test? Well, first of all, when you want to compare the mean ranks of an ordinal outcome variable of two groups to see if they're really different. We're talking about two groups for comparison, and we're talking about ordinal data. There is one additional usage of this test when we have two groups for comparison on interval data, but we find that that interval data is not normally distributed. We do a Shapiro-Wilk test, and we see that it's not normally distributed. We then go down a level and once again use the Mann Whitney U test as if we're talking about ordinal data. The two groups have to be independent, which means we have different participants in each group, and we need at least 5 participants' responses in each group. What are our hypotheses? Well, a two-tailed hypothesis is just a claim of difference. So the null hypothesis is that the two groups are the same. Our alternative hypothesis is the groups are different. A one-tailed hypothesis where we have a claim of a direction, so the null hypothesis stays the same, but the alternative hypothesis is one group is higher or lower than the other group. In our example, we do have a one-tailed hypothesis because we think that the meaningful literacy class, which includes poetry writing, should have there should be a higher preference for poetry, which actually means a lower score on the scale that we've got. So with that, we're going to go over to JAMOVI and look at the Mann Whitney U Test. So as you can see, I've opened up JAMOVI and I've already opened up this data set. Now let's do as we always do. Let's look at what variables I actually have here. So I have two variables, class type and poetry preference ranking. Let's look at class type first. I double click on this and it opens up the dialog box. And I can see that this is class type of writing class the student is training in. This is a nominal variable. And I have two groups, meaningful literacy is 1 and 101 is 2. Let's close this. Let's look at our outcome variable. So in this case, I have a poetry preference ranking. What measure type is this? This is an ordinal data because it's a rank order. And how's it defined? A rating for the student's preference for writing poetry. 1 equals most preferred and 5 equals least preferred. So a lower score, lower mean rank would suggest that we are talking about more preference for that particular type of writing poetry. Okay, let's do the test itself. So we're going to go to analyses and we're going to go to t-test. I'm going to open up that dialog and the independent samples t-test. So we've opened up the dialog box, and as you can see, this is the same dialog box as the independent samples t-test. And there's a logic for this that we're going to go through very shortly. So the first thing we do is we're going to put our variables in the correct box. So class type is our grouping variable, and poetry preference ranking, our ordinal variable, is in the dependent variables box. Now, because I have an ordinal variable, I don't want a student's t because that would be an independent t-test. I want a Mann Whitney U test. So I'm just going to click on that and unclick this. Okay. So the first thing we want to do is we want to look at descriptives, and we're also going to get a descriptive plot. So let's take a look at the plot first of all. And as you can see, the meaningful literacy, this variable is very close to the 1. It's in this range, which means this is a very preferred type of writing task. Whereas for the 101 class, it's far higher up. There's also quite a distance between the confidence intervals here. So I'm guessing that this is going to be a significant difference. The square box here and here, that is actually the median, and we can see the median for class type is 5 and the median for the meaningful literacy class is 2. So this once again suggests that we're going to have a significant difference here. Now, before we look at the Mann Whitney U test, we do want to define what our hypothesis is. It's predefined as just a difference, but actually we have a one-tailed difference. We think group 2 should be higher than group 1. In other words, we think that the 101 class should have a lower preference for poetry than the meaningful literacy class. So let us now go up to the Mann Whitney U test. You can see it here under independent samples t-test. And we can see that our statistic is 18 and the p-value is 0.007, which means that there is a very significant difference between these two mean rankings. And in actual fact, if we look at the median, we can see for the poetry preference ranking, we have a median of a 5, and for the meaningful literacy we have a median of 2. Now there's one last thing I'd like to do. There is a situation where we would use a Mann Whitney U test if we had a interval data set in which it was not normally distributed. So if I did a normality check, which is not appropriate for a Mann Whitney U if it's already ordinal data, as in our case, but let's say we're treating the preference scale as if it's interval data. If I ran a normality test, let's just see where that is. Here we go. The normality test of Shapiro-Wilk. I actually can see that this is significant at the 0.001 level, which in any case would suggest that this data is not normally distributed, which it is not, because it's ordinal data, and therefore I would be forced to do a Mann Whitney U test. So now the only thing left to do is to report this data. So now we need to report the results from the JAMOVI analysis from the Mann Whitney test. So the language we use for this is really simple. The results indicated that there was a significant difference between the poetry preference ranking for the meaningful literacy class, and then I report the median, and the 101 class, I also report the median, and then I give the U-test results, which is 18, and it's significant at the 0.007 mark. You can see with the arrows where to collect this data. This is a very easy test to report. I hope this video has been useful for you. I hope this helps you in your research and your future studies, and I look forward to seeing you in my next video.